today we are going to talk about position, velocity, and acceleration versus time graph. So I'm just gonna introduce like the basic stuff about what are these. So we use x of t to express position versus time graph, and velocity v of t means velocity versus time graph, and a of t means acceleration versus time graph. So a few things to mention that for velocity, it doesn't mean just speed. It means speed plus directions, which means like if you see it on the graph, it could be like a curve, such as something like this, because it can change direction at this point. And yeah, for the connection of those three functions, we can do it like this. When it goes down, the v of t is the derivative of x, so it means like differentiations from x to the a. So this is differentiation. And when it goes up, it means the anti-differentiation. It's pretty obvious. So which means like x prime of t equals v of t, and x double prime of t equals acceleration of t. Okay. I'm gonna introduce some very simple examples for the graphs to show how they relate to each other. First, we are going to draw position versus time graph. The x-axis is time, the y-axis is position, x. As I just said, I'm going to introduce you some very simple examples for each graph. So I'm going to write like the position graph first. The x-axis means time, and the y-axis is position x. And for example, we just do a linear with increasing curve. Okay. Means like, for example, here's the sensor. When you move away from the sensor with constant speed, the graph is gonna show like this. So this means like moves away and constant speed. And I'm gonna show you the velocity versus time graph corresponding to this one. The velocity of this one is going to be a linear curve. Y is the speed line, and like the x-axis, because the speed is constant, and it's going to be because when you are moving away from the sensor, the position is positive. So your speed doesn't change, and the position is positive, so your curve should be positive with like constant speed. The velocity is this. And I'm going to show the acceleration one. Time, acceleration. Okay. So the acceleration should be 0. Because you don't do any speed up or decreasing speed or increasing speed, because your speed is constant. So which in fact includes the acceleration like one maximum and one minimum. And look at here. This curve until this one is increasing, which means like the line above the zero should be positive. So this point is this point. It's the same thing. This point is this point. And for this part, it's decreasing. So it should be like negative, which is below the x-axis, which is this part. And so this point should be the zero. And looking at this part, it's increasing. So it should be above the x-axis. So it's this part. And looking at the acceleration graph, you can see both of them can show the it's not accelerating, the speed is constant, and it's kind of moving toward to the center, which means you have to change your position from negative to zero and then move away from the center. Since the speed is constant, the line should be linear for acceleration graph. That's what we talking about. Thank you. Okay, I'm gonna explain those graphs with more like actions.